Hello friends, myself Sriram Korde. We will take another example so that we understand how do we apply if else to a little complicated problem. Now let's try to understand what that problem is. So here if I am given three sides of a triangle, then I want to check whether those three sides triangle, whether it is a scalene triangle or whether it is an isosceles triangle or whether it is an equilateral triangle or it is a right angle triangle. That means how those three sides are basically together, so that whether it is isosceles, scalene, equilateral or right angle triangle. Now we are given only three sides. Okay, so that means now we need to take input and by doing the scanf. So that is fine. So now let's first identify the variables that we can use. So we can use say L1, L2 and L3. So these are the basically lengths of three sides. Okay, so that we can use. Okay, and then we will have user to enter those inputs. So we will have user to enter three sides of triangle. So we will say enter sides. Okay, and obviously we know that we are doing it for triangle. Okay, so we'll do scanf, and here we will have percentage d, and here we need to take three lengths or three sides essentially. So I have used L1, L2, L3, so that we know that it's for three lengths, okay, or three sides. Now once we know, now the question is how do I say that it is a scalene? So let's say that equilateral. What is equilateral? It's very easy. If it is an equilateral, then all the three sides, that means L1 is equal to L2 is equal to L3. That is very easy. Then when it comes to isosceles, only two sides are going to be same. The remaining is not going to be the same. So we need to check that properly. Okay, it is little tricky. Then scalene, all sides are not equal. So that is the most easiest way to do. Like all sides are not matching, so it is a scalene triangle. Okay, that means L1 is not equal to L2 like that. Okay, then L2 is not equal to L3 and L3 is also not equal to L1. So that is a very easy way to do that. So scalene, all the three sides are not equal. Here two sides are equal. Here all three sides are equal. And now the most tricky here is a right angle triangle. Why? Because when you have right angle triangle, then essentially you have the two sides like xy. Say if you consider xyz as a triangle, then how do you say that? So z square is equal to x square plus y square. So if that condition is met, then essentially we say that it is a right angle triangle. So let me just put it here. X, suppose if I have three sides of a triangle, and which we would have studied in our school days. So then how do I do? Or basically the diagonal, or some people call it as right diagonal, or the so like that. So I can simply say z is equal to, so if x y z, then we can simply say z square is equal to x square plus y square. So if this condition is met, then in that case I will say that it is a right angled triangle. Okay, that is essentially the diagonal I am talking about. Okay, the three side which is a larger side, and here the z I am talking about the larger side. So larger side square is equal to sum of squares of other two sides. So that is a right angle triangle, and this is little tricky. So we will solve all these things now. So let's first take scalene. So scalene, as I told you, it's very easy. You can simply put if condition, and we can simply say L1 is not equal to L2. That's what I told. Neither of the sides are equal. So L1 is not equal to L2, and basically L2 is not equal to L3, and L3 is not equal to L1. Okay, if this is going to be the case, then we can very easily say it's a isosceles triangle. It's very easy. Okay, it's a isosceles. Sorry, it's a scalene, not isosceles. Scalene triangle. Okay, so this is very easy to do that. Okay, now we have isosceles triangle. Now isosceles triangle is little tricky. Why? Because any two sides can be can be equal. Okay, that means now I have to have multiple conditions, or I have to put or conditions and do it. So otherwise it will look very bulky if I write, or very long logic. Okay, so we can probably put multiple ifs and we can handle it. So we can simply say if L1 is equal to, so let me just put it. So here I will say L1 is equal to L2. Okay. However, when I say L1 is equal to L2, then I have to obviously think, or I have to say that L2 is not equal to L3. Okay, why? Because only two sides are equal. It is the isosceles triangle. So here we are considering L1 and L2. Okay, so let me just copy this, and here we will say isosceles. Okay, so isosceles is not an issue. Now we are able to take care. Now similarly, I will have to do this isosceles because I told you it is little tricky but not that complicated. Now there could be a case where L2 is equal to L3. Then in that case, I will say L3 is not equal to L1. Okay, so again it becomes a isosceles triangle. Okay, why? Because L1 is same equal to L2, so that is first scenario. I could have put or here, but I don't want to clutter, and I'm purposefully writing it one by one. Okay, so L2 is equal to L3, and then in that case, obviously L3 should not be equal to L1. So that is the supporting thing, and then the last one will be if L1 is equal to L3, but L3 is not equal to L2. Why? Because only two sides will be same. Okay, so then in that case it is a isosceles triangle. Okay, now comes the equilateral triangle. Again, that is very easy to write equilateral triangle. So what is equilateral triangle? If L1 is equal to L2 and L2 is equal to L3. L1 is equal to L2 and L2 is equal to L3, then this is a equilateral triangle. Equilateral triangle. So again, this is not the issue. Okay. Now comes the right angle triangle. Okay. Now how do I check the right angle triangle? Okay. Now that is very tricky. Why? Because I have to check whether the square of distance, say S1, whether that square of S1 is equal to sum of the square of S2 and S3. So that is what I need to do. So it is little tricky, and let's solve that. Okay. So what we will do is we will see if, or another easy way could be I can simply check like this. Okay, I can simply check S1 or L1 into L1, L1 into L1, whether it is equal to what I want to check now is if L1 is equal to L2 into L2 plus L3 into L3. Okay, that is what I want to check. So I can use if statement here. If both are same, then in that case what happens? I will have to basically say that this combination essentially becomes a triangle. Okay, so that means now I require a separate some variables here, which I will use. Say I will use temporary variables T1, T2 and T3, which are going to indicate to me, or which are going to help me. So how it is going to help me? So here I will say T1 is equal to 1. What I am doing, if L1 square, that means if this condition is met, then in that case T1 is equal to this one. So I can initialize this to 0, I can initialize this to 0, and I can initialize this to 0. Okay, so similarly I will have to do else if I can do here, else if, and then the same condition I can do So here now it will be L2 square, L2 square. So L2 square is equal to L1 square plus L3 square. Okay. So if this is the case, then here I will say T2 will be equal to 1. That is the condition. Okay, only one will be true at a particular time. I am just purposefully using else if, it doesn't have any meaning as such. We could even get rid of this and we can simply put if, that doesn't matter. Okay, and then we will have third condition. Now is T1, T2, T3 really required? It's not required. Why? Because only one condition typically will be met when we have a right angle triangle. So I am just simplifying it, but typically we can simply say T will be equal to that, and then that is good enough. Okay. So that other condition will not be met because when we have a right angle triangle. Okay. So we can simply say T3 here, and T3 will be equal to 1. So here obviously you will have L3, L3, L1 and L2. Okay. So then in the end I will have to check if T1 ORed with T2 ORed with T3. That means if any of the thing is 1, if any of the thing is 1, then we can simply say right angled triangle. Okay, I could have even without this thing, I could have simply printed here and else if also it could have happened. Okay, I'm just telling you this is a relatively difficult one. I could have used even T1, so we'll do that optimization little later. Okay, so this is where it is a right angled triangle. Okay, so let's now run this code. Okay, so let me run this code now. So let's put 3, 4 and 5. So scale and triangle, yes, because all sides are different and essentially it is forming a right angle triangle. So why? Because 5 square is 25, 3 square is 9 plus 16, 4 square. So that's why it is a right angle triangle and it is correct. Okay, so what we should do now is basically we should put n, then everywhere we should put here, and then in the this one we should put slash n so that it goes to the next line. Okay, now the important point is was this all logic required? It was not required. We could have simply used t. Okay, so instead of this we could have used t is equal to 0. Okay, we could have used t is equal to 0. We initialized it to t is equal to 0, and then we can simply use whenever that particular thing is a condition becomes true, then we could simply use t. So let's see this logic, and then here we could simply say if t. That means if t is equal to 1, then only this will run. Okay, or this will basically work. So let's run this, and we can enter, let's say 3, 4, 5. So scalene, and it is right angle triangle, it is working perfectly. Okay, I just made else if also I could have used, I told you, so that can be done as part of optimization. So let's run this now. So let me now put 4, 5, 5. So it is an isosceles triangle. Okay, so that is correct. Let's run this. We'll keep it 5, 7 and 8. Obviously it's a plane scalene triangle. Okay, now let's keep say 10, 10, 10, 10. So it's a isosceles triangle. Yeah, so I think we have somewhere we basically have done it. So here, okay, so there was a mistake here. You can see this is the way you should typically solve this. So this is L1 is equal to L3, and L3 is not equal to L2, so it should have been L2, so I missed it. Okay, so let's solve this now. So we can catch the error also like this. So let's do it now. 10, 10, 10. Yeah, so that is correct now. Okay. So that's the way typically you handle the problem. It is little complicated problem, especially when we wanted to check whether it is a right angled triangle. So we handled it properly and we could solve this question. I hope you like this problem. Thank you.